Okay, 8.3, graph exponential functions. So we've already kind of talked about exponential functions. We're going to work more with them today. I need a reader. Would somebody like to read this first part right here for me? Okay, Hope.
Many real-world phenomena can be modeled by functions that describe how things grow or decay as time passes. Examples of such phenomena include the studies of populations, bacteria, radioactive substances, electricity, and temperature. Any quantity that grows or decays by a fixed percent at regular intervals is said to possess exponential growth or exponential decay.
Very good. So again, remember how we read graphs from left to right. So if you notice here, see how this is going down, that is why it is decay. On this one, it's going up, and that is growth. Are we all okay? All right, so it says, the time required for a substance to decay and fall to 1/2 of its initial value is called the half-life. Radioisotopes of different elements have different half-lives. Number 1, when a plant or animal dies, it stops acquiring carbon-14 from the atmosphere. Carbon-14 decays over time with a half-life of 5,730 years. How much of a 10 milligram sample will remain after 22,920 years? I know this is all pretty exciting stuff that you guys are really curious about. So, all right, but I'm going to show you, this sounds complicated, but it's actually not that bad. I'm not. No, I promise. I'm going to show you how easy it is. When you have your homework, you're going to underline, circle, highlight. You guys have your own homework packets that you can do that in. Okay? Here they're giving you this formula. Okay? Notice to the side it tells you N sub O, that's how you'd say that, is the initial amount. Then they tell you that this N is the amount remaining, T is time in years, H is your half-life. Well, if you go up here, they give you the same information as well. Right here they said the half-life is 5,730 years. Do you guys see that? So where is that value going to go? It's going to go in for the H because they told you that H is half-life. It tells you, it says how much of a 10 milligram sample will remain. So is that, where does that N go, do you think? Yes, because that's your initial amount. You're trying to find how much is going to remain after that amount of years, right? So, if we're going to this problem, this value right here, the N sub O, your initial amount is 10 times 1/2, and then T, time. What's my time? 22,920 divided by 5,730. Okay, for some of this, you guys will want a calculator, I'm sure.
No, I couldn't figure that out in my head. Did you know?
When you divide those two numbers together, they reduce to 4. You're amazing, Blake. Okay. Now, what is going to be my next step once I do that?
You'll multiply the one, or I don't know. But you'll reduce the 10 and 1/2.
Nope. PEMDAS says you do what? Exponents first. If you do 10 and 1/2 first, you're going to get the wrong answer. Okay? 1/2 to the 4th power. What is 1/2 to the 4th power? 1 over what? 1 over 16 is correct. And then we're multiplying that by 10. Can I cross cancel or reduce anything here? What goes in about 10 and 16? 2. So I'm going to make that a 5 and this an 8. So I end up with 5/8. And this was in terms of milligrams. So 5/8 of a milligram is remaining after that amount of time. It was. Yes. Oh, because you and Rex and people were talking and you weren't listening?
I don't get it. I don't get it.
Okay, so this right here is called an equation. Okay? Over here, they're explaining to you what each of these things in this equation represents. In this problem, they're giving you information. I highlighted, this said half-life is 5,730. Right here, H, 5,730. They said a 10 milligram sample, they want to know how much will remain after that amount of years. So that means this is my initial amount. Okay, that is my 10. And the time was the 22,920. And I'm trying to find the answer of N. So all we did was plug in these numbers. So I plugged in the value for T, the value for H, the value for my N sub 0. I divided that, which reduced to 4. PEMDAS tells us, or order of operations, that we have to do exponents first. So that's why I did 1/2 to the 4th power, which is 1 over 16. So then I just had 1 over 16 times 10, and I reduced it and got 5/8. So that's the amount of sample that it started at 10 milligrams. This is what's remaining after 22,920 years. Just in case you guys are around that long and want to see what's left. Okay? All right. Okay, next problem. Okay, example 2. One certain element decays over time with a half-life of 800. I know half-life is important. So I'm going to go ahead and highlight, underline, box, something. Okay, use the formula to determine how many grams will remain after 3,200 years if 500 grams were present originally. So, what is my value for A? 500 is correct. Times 1/2. My time, my T is what value?
3,200.
Very good. 3,200 divided by H, which is
800.
800. Yep, that reduces to 4. Remember that if you have zeros, the zeros cancel, and we just have 32 divided by 8, which is 4. 1/2 to the 4th power is what I do next, because we have to do exponents first, and 1/2 to the 4th power is 16. So I have 500 times 1 over 16. Can 16 and 500 reduce it all?
Maybe by 2 or 4.
Okay, let's try. What do you want to try first?
2.
Okay, 2. So that would make this an 8, and that would make this 250. Can I reduce by 2 again? Okay, so that would make this a 4, and this would be 125. Can it reduce any more? What?
No, never mind.
Yes.
So that is my answer. 125 divided by 4 grams. Or if you want to write that as a decimal, it would be 31.25 grams. Either answer is good. Questions? Okay, I'm going to give you about a minute to try to do number 3. We'll talk about it first, actually, and then you're going to try it on your own. So, half-life, the radioactive gas of radon has a half-life of approximately 3.5 days. About how much of a 300-gram sample will remain after 1 week? Now, what do you notice here? Does anything jump out at you in this problem when you're reading it? Weeks and days. Do you think you can have weeks and days when you're figuring out a problem like this? So you need to change either one of them, both of them to weeks, or both of them to days. Which would be easier?
7 days.
7 days. So pay attention to that stuff. That's going to be 7 days. Oh, and even said right here. Okay, I'm going to leave you guys alone. Try to get number 3 on your own. If you get the answer, if you write on your whiteboards, that would be awesome. can see some answers here. Good, 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 good. I like how you are using units. You should have an answer in terms of units, not just a number. Good. Yes, yes, good. No. All right, so the answer should have been 75 grams. Hannah. Okay, so she's just using somebody else's answer. Oh, no, I'm just giving you bad timing. It's totally fine. Okay, so, oh my goodness. 7 divided by 3.5. What's 7 divided by 3.5? 2. 1/2 to the second power is what? 1/4. And then 300 divided by 4 ends up becoming 75 grams. All right, example 4. A lot of you have this. Geekonium.
Wow.
Exactly. I have it too, says the math teacher. I like that. Okay. The half-life of Geekonium is, Geekonium 25 is 2 years. Okay. Find how much of a 240 gram sample remains after 4 years. Okay, so what's my initial amount on this? Very good, 240 is correct. Times 2 to the negative, and what's my t value? 4 divided by my half-life, which is 2. Negative 4 divided by 2 reduces to what? Okay, so we have negative 2. What do I do with negative exponents?
You have to bring it to the bottom.
Good. So you have to take this negative exponent here and bring it to the denominator. So I end up with 240 times 1 over 2 to the second, which is 240 times 1 over 4, and that ends up becoming, again, if you aren't sure, divide by 2. So 2 goes into here, and this becomes, and that 2 cancels out with 120 and becomes,
Did that become 60?
yes.
I was right. I just did 20
So the-
divided by 4 and then added the 0.
60 grams. Again, don't forget your units. All right, so example 5. They're pretend.
I know, but they're just weird. Like, oh my gosh.
Okay, so on this one, it says, here's your equation. Half-life of begonium is 4 hours. How much of a 24 gram sample will remain after 6 hours? Okay. So when we plug this in, I have 24 times 2 to the negative 6 over 4. Okay, which is really reduces to negative 3 over 2. Notice that this is a fraction, okay? When we change it with the negative exponent, we get 24 times 1 over 2 to the 3 halves. What you need to think about is that 3 halves is really 1.5 or 1.5. That means 1.5 is in between 1 and 2. Do we all agree with that? So like on a number line you have, here's 1, here's 2, in the middle is 1.5, right? So what you can do is we can estimate and we can figure out our answer by using 1 and 2. Do you understand what I mean? So I'm going to use the exponent of 1 here. If I had 2 to the first power, I'd just end up with 1/2, right? And 24 times 1/2 becomes what? 12. Good. If I use 2 here, 2 to the second power would make 4. And if you have 24 times 1/4, what happens? What do you get? 6. So that means for 1.5, my answer is going to be between what two numbers? 6 and 12. What are the only answers that are between 6 and 12? C. So I'm going to give you a second to process this. Does anyone have questions they want to ask me?
I do not. Can you please explain that again?
Okay. So we're all good with these numbers. We understand the negative goes to the denominator. Everybody's okay there, right? Do we all understand that 3/2 is really the same as 1.5? 3/2, if you're not agreeing with me, if you divide 2 into 3, 2 goes into 3 one time. 1 times 2 is 2. We subtract 1 left over. That's 1.5. If you divide it into a calculator, I don't know why that's blurry. There we go. You would get 1.5. 3 divided by 2 is 1.5. Okay. Well, 1.5 or 1.5 is in between the numbers 1 and 2. I can put the exponent of 1 in here and get the answer, and the exponent of 2 in here and get an answer, and know that 1.5 is going to be between those two values. So what I did was I did 24 times 1/2 to the first, and I did 24 times 1/2 to the second. And I found out each of those answers. So I found out the answer if this number had been 1, and I found out the answer if this number had been 2, and that gives me an idea of what the in-between value would be. So if I plug in 1 for that fraction, I got 12. If I plugged in 2, for my exponent, I got 6. So I know that the exponent of 1.5 is in between 12 and 6. Okay? So anytime you have a fraction, you want to figure out the whole numbers that the fraction's in between. And then that will give you an estimate of what your in-between number would be. Okay. Okay, let's see what you can do. I'm going to not talk at all on this one. Make sure you convert something. And when you get your answer, show me on your whiteboards. And don't forget it doesn't say what it is, so I would just write units if it doesn't state what it is. Perfect. Nope. Yes. Perfect. Good. Yes. Cheater. Yes. Good. Yes. Yes. Okay, so the correct answer should have been 640 units. How many of you got it correct? Okay, so most of you got it right. A few of you are still working. Okay, so a culture of yeast doubles in size every 20 minutes. So is this a growth or decay? Growth, because it's doubling. It's getting bigger, right? So make sure your answers match what the question is saying. The size of the culture is now 80. So it's saying it's now 80. It's not saying that it started at 80. It's saying that it is... Oh, wait a second. Am I doing something wrong? Okay, find its size in 1 hour, which should be 60 minutes. Okay, so it's saying that right now it's at 80 and it wants you to find it in 60 minutes. So you're going to go ahead and decide that the initial population is 80 because that's your starting point. Okay, so 80 times 2. Now, what's going to go in the t value? 60, and they kind of tricked you because they already put the 20 in. So be careful sometimes because sometimes they put the information in the equation. And that reduces to what? 3. And 2 to the third power is 8, and 80 times 8 is 640 units. All right, example 7. The growth of a town is given by this formula. If there are 4,000 people after 4 years, find the initial population. So this one you're working a little differently. You got it. You guys want to try it on your own? So this one you're finding the initial. You're not finding right now. Like you got it. Good. Yes. Good job. Remember that this time you're finding the initial amount. They're not giving you the initial amount. You're finding the initial amount. They didn't give you the initial amount. Perfect. No. Okay, I'm going to give you about 20 more seconds if you haven't got the answer to give it a try.
Oh, I know what I know.
Perfect. Good.
Sorry, it's already set for me.
All right, so yes, the answer is 250 people. Okay, so 4,000 people after 4 years, find the initial population. So we don't know the y sub 0, okay? If you end up wanting to write this as x when you're figuring this out so it's easier to see, you can do that. But so they're telling you that the answer is 4,000 people equals, I don't know what my initial population is, and then it's 2 to the 4th power. What is 2 to the 4th power? 16 is correct. How do we get rid of that 16 with the x? Good. Divide by 16 to both sides. And if you take 4,000, you divide it by 16, you get the answer of 250 people. Okay, last example. The number of people with the flu virus is growing exponentially with time as shown in this table below. This is probably something similar to what our government, county might be looking at right now, right? Yes. So it says, which of the multiple choice equation expresses the number of people n having the flu at any given time x? They give you this chart. You're trying to figure out which one of these equations is correct. I personally think dealing with 0 is the easiest. This is like your x value and your y value. Or, if you're looking at these down here, you're plugging in the days, you know, the time. So you're trying to see which one, if you plug in 0, is going to give you an answer of 300. If I plug in for A, 2 to the 0 power, what does it make?
1.
But 300 plus 1 is 301, and they're saying the answer is 300. So is A going to work?
Nope.
No. 300 to the 0 would be 1. B does not work. 2 to the 0 is 1 times 600 is 600. And here, 2 to the 0 is 1, and 300 times 1 is... So D is correct, and a lot of you already said that.